understanding the meaning of systems of linear inequalities. So with that in mind, let's go ahead and begin. So in this question, we have a lot of information. The first is that x represents time in hours and y represents the distance in miles. I will be moving back and forth between slides so that you can see the graph and then the questions. So the following is the first one. So it's asking, is the graph a function? If it is or is not, explain the reason. So let's go ahead and take a look at what they're referring to. So here we have a graph, and in this graph we have here our time in hours, and then we have our y-axis, which represents the distance in miles. And this was already given in on the previous slide as given information. So it's asking, is it a function or not? Now, the quickest way to tell is by simply drawing a series of vertical lines that cuts through the graph in as many places as possible. Now, the point of doing this is to see if your vertical lines intercept the graph more than one time each time. And it only takes one of these vertical lines to intercept the graph in more than one place for the graph to be not a function. And so in this case, you can see that I have, for each blue vertical line, I have one red point which represents one intersection between the blue vertical line and the graph. And that indicates that it is indeed a function. And so that covers the answer for number 1. Let's go ahead and take a look at the next question, which was, find a reasonable domain and range for a trip that lasts 5 hours. So it's getting very specific about what it wants us to consider here. And so for 5 hours is right over there. Again, this is our domain in terms of time. So domain has to do with the horizontal width of the graph. So how wide is the graph from its beginning to its end? So this graph starts there and ends right there. And so at its starting point, the number of hours is 0. And so my domain is going to be 0. And then it's going to go all the way up to the number 5. Now, what you put in the middle can be either hours, since this is the idea of the domain, or you could represent it by just putting x, which is the name of the axis it's on. So the hours go from 0 to 5, and because we have to include both those times, we put the less or equal to. This is a conjunction, so the x being in the middle of or between the 0 and 5 indicates that the time frame we're looking at is between 0 to 5 hours. The range has to do with the height of the graph. So from its lowest to its highest point, how tall is this graph? So if I look at this, I can see that we begin at 20 miles and we end at 45 miles. If I extend this out to the 5th hour, it's 45 miles. So 20 to 45, and then because this has to do with distance, I can write this as the idea for the range, or I could simply put y as the name of the axis. And because the distance covers 20 to 45 miles, and we have to include those numbers, we put the equality part in the inequality, so less or equal to. The next question is find the absolute max and min and interpret what it means. So going back to the graph, the absolute maximum has to do with the highest y value on the graph. So if I go to the highest point on the graph and I go all the way out, I can see, oh, the absolute maximum is at 45 miles. Whereas the absolute minimum is the exact opposite. So it's the lowest part, the lowest y value. and this is at 20. So this is the absolute min, 20 miles. Okay? Sorry about that. And the last question is, what is the function? What is the function of this graph? Now we have to answer this in terms of slope-intercept form, which is y equals mx plus b. The b part here, you have to remember the b part, this always represents the y-intercept, and the slope always represents, or the m always represents the slope. So the y-intercept is simply the place where the graph intersects the y-axis. So if I look closely, that's at number 20. So this becomes a positive 20. The slope is something that I will need to either count or calculate. Now, I'm going to grab another clear point, which is right there. And this is at 1 hour and 25 miles. This 20, by the way, is really 0 hours and 20 miles, because that's where we began. 20 miles away from something, and then an hour later we were 25 miles away from that starting point. So, so in order to get the slope, we have to remember that slope is the changes in your y's versus the changes in your x's. And so the change in y here, if I'm going from 20 to 25, the change is 5. Okay, so there's a 5-mile change. And then I went from 0 hours to 1 hour. So that's a change in time of 1 hour. And 5 divided by 1 is simply 5. So now I can write the function, or the equation actually, as y equals 5x plus 20. Now, technically I'm done. However, the task was to write a function. And so to be true to that, I'm going to simply take the y and write it as function notation, which would be f of x, or you can use g of x or h of x, it doesn't matter. But f of x is equal to 5x plus 20 would be the function notation for this line. And again, it means the same thing as just saying y equals 5x plus 20. That y and that f of x are interchangeable with each other. Okay. Moving on. So the next question we're going to look at is similar to the one that we did, but the difference is that the graph, as you can see over here, is clearly different because of a couple of reasons, and we're going to get to those in just a minute. But I want to tackle this again. So it's asking a similar question: is the following a function? So we're going to go back to the graph, do our vertical line test. And you can see that, yes, indeed, at every intersection point, I have only one point. And that means that, yes, this graph does meet the criteria for a function. It is a function. As far as domain and range, which is this one over here, what is the domain and the range of this? The answer to that this time will be slightly different. And there is a reason for this. So let's start with domain. Okay, so domain again has to do with the sorry, I misspelled domain there. Domain has to do with the width, right? So this graph, which happens to be called a parabola, this graph has arrows at both of those top areas there. And what this means is that it's going to continually extend. As you can see, it started off, or it's kind of narrow at the bottom, but then it extends widthwise. It gets wider and wider and wider. And because these arrows indicate a direction toward infinity, this graph is going to continue to open up and get wider and wider as we go farther up. And because the width is going to increase to infinity, the domain of this goes from negative infinity all the way to positive infinity. And in this case, we're not dealing with any particular idea, so we can just put x in the middle as the name of our axis. because you cannot actually put your finger on infinity and say, aha, this is where infinity stops. The inequality cannot have an equal part to it. So you simply write less than at both ends, and we have a conjunction representing the domain going from negative to positive infinity. The range for this is going to also be different from the last time. The range goes from the lowest to the highest place on the graph. Well, the lowest place on this graph is -9. It's right here, -9. So I'm going to put that here. The highest place, however, has no highest place. And the reason, again, is because this graph is being shown to go toward infinity. It's going to go higher and higher and higher without any limits. So it's going to start, it's going to go at the lowest to -9, but it's going to go as high as positive infinity. The range is represented by y, and at -9, our points are closed. So I do need to put that equal component in the inequality, but because you cannot put your finger on positive infinity and say, aha, that's where it stops, you leave the equal component out of it and you just put less than. And that's the domain and range for this graph. The relative maximum and minimum. I just realized I skipped something. Is a graph discrete or continuous? Let me go back to address that real quick. This graph is in fact continuous, and continuity has to do with the fact that a graph is unbroken as you follow through it. So the fact that this graph continues indicates, and it continues forever, as I mentioned before, it is in fact continuous for that reason. Okay, pretty simple explanation. What is a relative maximum and minimum? So I'm now looking at this question here. Relative maximum and minimum. Okay. The relative maximum, in this case, the graph has no relative maximum because the graph just continues going up and up forever. It does have a relative minimum, however, and the relative minimum is right here, or to be specific, the relative minimum is right there. The relative minimum and maximum have to do with a place where the graph changes its direction. Either it was going down and now it swings and it's going up, or it was going up and now at that point, that switch point, it's now going down. So in this case, this graph is going down, 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 and right there, that's the switch point. And from that point, it goes up and up and up. And because this is the lowest place, right? It was going down and then it switches here and then it goes up. This is called a relative minimum, which just so happens to be the absolute minimum as well. The relative minimum is specifically at -1 and -9. Okay, you have to indicate that as an ordered pair because it's a specific point. It's a switch point in the direction of the graph. So ordered pairs for those. Okay, in this question, we're being asked to evaluate a function. Evaluating a function is another way of saying take this number I give you and simply go and find the variable that it belongs to and replace the variable with the number, then do the math and you're done. So you can see over here we have f of x, and in this f of x, this x is also appears right there. That's because the x is the input, and input, if you turn things around, means to put something in. So it's to take the, so we're going to take this negative, or excuse me, the +3, we're going to grab this number and we're going to bring it over to that x over there and to that x over there. And when you rewrite it, it becomes f of 3 is equal to -3. Now this is multiplication, so it's -3 times 3 plus 2. And then you go ahead and do your math. So this would be negative 9 plus 2, which would be negative 7. And so you could say, when I use a 3 as my input, what I get as an output is my negative 7. So this was my input. And as a result of that, this became my output, okay? Or the result of using my input. In the second scenario, though, we have f of x is equal to 8. And all that means is that this time you're being given the output and you're supposed to find the input. Okay, so this is your output and you have to find the input. So we're going to work backwards here, and I'm going to take this 8 and I'm going to replace all of this with that 8, because it's saying f of x, when you see f of x, make it into an 8. So it's 8 is equal to negative 3x plus 2. And now we have a two-step equation that we have to solve. So to do that, I simply subtract 2 on both sides. I get 6 is equal to negative 3x. When I divide by negative 3, what I get is x is negative 2. Okay, so the idea is backwards in this case, and so the way to understand this is in two ways. When your input is negative 2, your output is positive 8, or when you have an output of 8, that means that what created it was an input of negative 2. Okay, moving on. So here we have to, the directions are, we're supposed to create a graph of the equation that you see here by making a table. So making a function table is quite simple. There are many ways to do it. In its most basic form, you have simply x and y, and so I'm going to do that over here. We're going to take the function and evaluate it on the right side. Now, when you're told to make a table, most likely you're not given any inputs to use, so you have to choose your own. I always recommend that you keep a good balance of 0 and a negative 1 and a positive 1. You really only need 3 order pairs to make an accurate line. So I'm going to go ahead and evaluate. So taking the negative 1, what I get is negative 7 times negative 1 plus 3. And I'm going to create a little more space here so it's not too cluttered. So I'll space it out a little bit. 1 will go there. So what I get is negative 7 times negative 1 is 7 plus 3 is 10. Okay, so with 0, I have negative 7 times 0 plus 3. And that's going to be 0 plus 3, and that's therefore 3. The last one is 7 times 1 plus 3. That's going to be 10. Sorry, I did this incorrectly. This is actually a negative 7. So it's negative 7 times 1, negative 7, plus 3, negative 4. All right, so out of these three data, I can only really graph these two. I can really only graph these two here. And the reason for that is because my output is when I have a 10, is out of bounds. So I don't want to stretch my coordinate plane and guess where the 10th level will be. So I'm just going to go ahead and plot my 2 points based on the last 2 points of data. So 0, 3. 0, 3 would be right here. That's my y-intercept, which, by the way, is right there. That is not a coincidence, in case you're wondering. And then the second point is 1, negative 4. So 1, negative 4 is right here. And as soon as you have those 2 points, you can go ahead and you can make a good line for yourself. I always recommend using, straight edge. Anything can be used as a straight edge, by the way. Doesn't have to be necessarily only a ruler. Of course, rulers help. And there you go. Let me do that again so it's not highlighted. There. So this is our line. and it goes through the 2 points that we got from the table, which was created based on the equation. There is another way to graph lines without the use of a table, but that's a higher concept level scenario, and we're going to look at that scenario a little bit later in this video. Okay. All right, so we're now moving on to a linear functions review, and we're going to go ahead and start with getting the slope of a line. Now, getting the slope of a line is easy when you have 2 points indicated for you, but when no points are indicated, then you have to pick those points yourself. So you want to go for a good corner. So I see one right there, and then you want to pick one that is as close to the other as possible. That will avoid having to reduce your fraction at the very end, and you can get right to the answer in its final form. So here, I have, actually, I'm going to start this over, and I'm going to zoom in so that things are a little easier to see. So, that's much better. Okay, so the point that I had marked was here and right there. There are a couple of ways to do this. When you have a graph and you're pressed for time, the fastest, best way to get the slope is simply just count the squares. The direction you take does not matter, and I'm going to make a point by demonstrating this for you. If I call this point A and the other one point B, and I want to go from point A to point B, okay? If I want to go from point A to point B, then I would first have to go down 1 unit, and going down represents a negative direction. And let me just indicate this right now very clearly. When you're going this way on the x-axis, when you're going in that direction, you're going in a positive direction. When you're going this way, it's a negative. Along the y-axis, when you're going down, you're going in a negative direction. But when you're going up, you're going in a positive direction. So with that in mind, let's go ahead and continue where we left off. So I'm going down 1, so it's a -1. Okay, -1. Then I have to go across 2 units. Because I'm going to the right, as I've already mentioned, this is a +2. Now the slope for this would be the change in y over the change in x, and that would be, according to what I just did, the change in y was -1. I went down 1, and I went 2 to the right, and that was a +2. So your slope is -1/2. If you want to go the other way, however, if you want to go from B to A, you want to go this way now. So to do that, you would have to go up 1. So it's just the reverse of what you did before. So you're going to go up 1. And because you're going you're going up, it's a positive direction. So +1. Then you go 2 units, but this time to the left. And because you're going to the left, it's a -2. And so the slope this time would simply be +1 over -2. Now, if you're wondering whether or not these two answers are the same, they are in fact the same. Okay, the only difference is that the negatives are in different places. But if you take a look at -1 over 2 versus 1 over -2, all it's saying, which is different from each other, the only difference is that this is saying to go down and right versus up and left. But as you can see, you end up on the same line, just in a different way of getting there, and you end up at a different point based on where you start. Okay, so let's move on to the next question. And in this question, we have to find the slope again, but we're not given any graph to look at. But that's okay, because there is a way to do this very, very easily. All you have to know really is how to add, subtract, and maybe do a little division. So the idea for slope, or rate of change, is that slope is equal to the changes of your y's over the changes of your x's. Okay, so it is a literal meaning. that means that if you look at 15 and you look at 1, they're not the same thing. The 15 changed into a 1 in very much the same way that a 1 changed into a 15. Okay, so it's a change of the values themselves. The direction you take does not matter. So if you want us to start with 15 and say, hey, my 15 changed into a 1, it would be 15 changed to a 1, or 15 minus 1. If you take that direction, though, then you have to make sure that you do the same thing with your x's. So you say you go with -2, changing into a -17. So -2 changed. And I'm going to slow down here because we're changing into a negative. So it's a double negative we end up with. So -2 minus -17. -2 changed into a -17. This minus in the middle represents the idea of changing from one thing into another. And now we have to go ahead and simplify. So 15 minus 1 is 14. I get a double negative here, so it's now a plus 17. So it's 14 over 15, and that is the slope. Okay, here we go. Next question. Find the slope of each line. Oh, actually, never mind. I didn't want to do that one. So from here, we're going to just look at a bunch of random questions pertaining to other Algebra 1A topics and categories. Here, we're going to sketch a graph of a line. Now, in order to do this, you have to understand the forms of the equations for lines can be one of three things. It could be either slope-intercept, point slope form, or standard form. This one happens to be standard form. Now, it is possible to graph from standard form. It's possible to graph from standard form. You would have to get what are called the x and y intercepts in order to do that. If you don't have space within your coordinate plane to do this, or you don't want to do it that way, or you don't remember how to get the x and y intercepts, then you can simply change this into slope-intercept form. And so that's the approach I'm going to take, actually, only because I kind of see that I'm not going to have enough space to put one of my intercept points. So to change this into slope-intercept form, which is going to be y equals mx plus b, to change it simply involves understanding where you have to end up. So your y must end up isolated on one side. In order to do that, you have to take your x and move it to the other side. Okay, because your mx is joined together on the same side with the y-intercept. So in subtracting x on both sides, what I get is 2y is equal to -x plus 8. Then I have to divide. And when I divide, I must divide everywhere. So now I get y equals -1 over 2 x plus 4. And this is something that I could actually graph. The way to do that by simply looking at the equation is to remember that this right here, this is your this is where you begin. And you begin at the y-intercept. So I'm going to go to my coordinate plane and put a point at 4 along the y-axis. There it is. Then you wait there. You don't move and reset back to the origin. You stay at 4. And now you activate your slope. The slope is -1 over 2. This means that you're going to have to move down from your y-intercept. You move down 1 unit, and then you move to the right 2 units. So if I apply that, down 1 unit to the right 2 units puts me right here. And now I'm in a good position to make my line. So my line is going to look like this. Okay, and that's the end. All right, let's go ahead and move on to the next one. Okay, here we have to write the slope-intercept form of a line that goes through this point. I'm looking at this question right here. So we have to write the slope-intercept form, which is y equals mx plus b, using the fact that there is a line that cuts through a point here and here. So in order to write this equation, it's always good when you're given ordered pairs. It's always a good idea to see if you can identify whether or not one of those sets is the y-intercept. Because if you have that, the work becomes so much easier. So in this case, I'm given the y-intercept right here. And the way I know that is because my x value is a 0. So if my x is 0, that means that my y-intercept would be something like right there. Okay? So whenever you have an x value of 0, your y value automatically becomes your y-intercept point. And so what I can do is go right ahead and drop this number into that spot there, and this equation transforms into the following. What I get is y is equal to mx plus 4, because that 4 is positive. Now, I still need a slope. I need something to go there. I can't just walk away from mx plus 4 and say I'm done. So I do have to calculate the slope, but doing so is easy if you remember the last few examples. So my slope is the change in y over the change in x, which, if you borrow the numbers here, would be something like 4 minus 2 over 0 minus negative 1. Again, you can go the other way and say 2 minus 4 and then negative 1 minus 0, and nothing would change. It would still be the same value at the end. So 4 minus 2 is 2, and 0 minus negative 1 is 1, because of that double negative turning positive. This becomes a 2, and there is my slope. So now I can finish this by saying this equation is y equals 2x plus 4. And this, if you were to graph it, would create a line that cuts right through this point and this point. Okay, on to the next question. So next question is write the standard form. So now we're going to write the standard form, which is ax plus by is equal to c, of a line that cuts through these 2 points here. So this one and this one over there. Standard form is a little different from slope-intercept and point-slope form. To get standard form, there are different ways, but the way that I want to take is I want to take the route of using point-slope form and then transforming it into standard form. So I'm going to have to go back and do a quick review of point-slope form. So point-slope form, the meaning of the name is in the name itself. So point-slope form is good when you have a point and a slope to work with. I have 2 points to work with, actually, and they are, as I said already, this one here and that one right there. So I have 2 ordered pairs representing points, or I have 2 points. All I need is a slope. And then I can write this equation here. Y minus y1 equals m times x minus x1. The plan is to first complete this equation, and then once it's done, I'm going to change it into this form. Okay, so that's my game plan. So I need the slope first, and this is quick work. So slope is going to be my change in y, which is negative 3 minus 3. If you're going, and again, keep in mind the direction. So if you're going this way, negative 3 minus 3, and then 1 minus negative 5. Okay, you're going that way. So negative 3 minus 3 is negative 6, and 1 minus negative 5 is positive 6, which creates a slope of negative 1, which is nice, a nice number to work with. So plugging that in, I have negative 1 right there. Now, I need to borrow one of my two order pairs because, again, they each represent a point, and I'm using the point slope form. So it doesn't really matter because they're both on the same line anyway. I'll take the first one. In the first one, the 1 is my x and the -3 is my y. So placing these numbers in the right spots of the equation, what I get is I get y minus -3, because the y I'm using to plug in is the -3 from the order pair. And then on the inside, I have x minus 1. And that x sub 1 became the 1 from my order pair. Now, this equation is all filled in, but I have to simplify it. So it's going to be y plus 3 is equal to negative, and I'm going to go ahead and distribute here. So negative 1x plus 1. Okay, so I have to begin to distribute in order to show that I'm changing it into this form here. Okay, because that was the game plan from the beginning. So now, to make this into standard form, one thing that you should note is that standard form involves the x and y's being together on the same side. Also, your leading coefficient, which is your a, cannot be a negative value, nor can it be a fraction. So I have to be careful to ensure that what I end up with meets those criteria. So going back to my my point slope form down here, if I were to add x on both sides, because again, I want to join the x and y's together. So if I were to add x on both sides, what I would get is x plus 3 is, excuse me, I missed one. I missed something. X plus y plus 3 is equal to 1. But this 3 now has to join the 1 on the right side. So what I'm going to do is I'm going to have to subtract the 3 on both sides. So minus 3, you can't really see that. I'm going to erase this, and I'm going to move everything to the other side. I apologize about that. I just don't want you to try to guess what I'm writing here. So I'm going to move it over there. This is x plus y plus 3 is equal to 1. And then I said, if I subtract 3 on both sides, what I get now is x plus y is equal to -2. And there you go. That's standard form. So just going back and rehashing what I started with and how I did this, the game plan was end up with standard form. To get to standard form, I had to go through point slope form, because I knew that I could transform point slope form into standard form. So I first had to get the slope. Then I borrowed one of the ordered pairs, which represents a point. I substituted all my values into the point slope form equation. Then I distributed, I simplified, I solved my equation so that I could get x and y together on the same side, and I ended up with standard form. All right, let's move on. All right, so we're moving into the next learning target, which is a review of linear inequalities. When you're doing linear inequalities, especially when you're graphing them, they mimic in a lot of ways the same principles for graphing linear equations. The only difference is that rather than having one solution or one order pair for an equation, you have limitless order pairs that satisfy the inequality. And so let's go ahead with that and graph this thing. So to graph this, you have to be, or you should be, in slope-intercept form. Now, normally slope-intercept form is y equals mx plus b, but because our equal sign is actually one of 4 things, it's still slope-intercept form, but just keep in mind we're not dealing with only equality anymore. But the idea is still the same. I want my mx to be away from my y, and so what I'm going to do is I'm going to begin to rearrange things over here. So I'm going to start over here and just rewrite this as 4x minus 3y is greater or equal to negative 3. Now, I'm going to subtract my 4x from both sides. This goes away. I get negative 3y is greater or equal to negative 4x minus 3. Now, I have to divide by negative 3. And again, I do this everywhere. This becomes a 1. Now I have y alone, which is good. But because I divided by a negative, the principles of inequality say that your inequality symbol must reverse its direction. The reasons for that I will not cover here, but there are very valid, legitimate, logical reasons for why this should be done. And I encourage you as a viewer to explore and learn the reasons behind it rather than just memorizing it as, oh, this is just something I have to do because my teacher said so. So anyway, so the negatives, when you divide, become 4 over 3. And then negative 3 divided by negative 3 is plus 1. So this is going to be my my guide for graphing. All right, so to graph this thing, I'm going to start at my y-intercept, which is positive 1. So here it is, positive 1. And then I'm going to go up 4 units and write 3 units. So 1, 2, 3, 4, and 1, 2, 3. And now I'm ready to make my line. Before I make it though, one thing to remember is when you're dealing with linear inequalities, the line you get can now vary between one or two things. It can be either a broken line, or if you have the equality component in your inequality, it would be a solid line. Okay? In much the same way that you have, for these inequalities here, you have on the left side, you have an open dot. But for the ones on the left, you have a closed dot. Okay? So it does translate into the type of line that you get. So, having said that, let's go ahead and make our line. As soon as my computer is willing to activate my, there you go. All right, we're in business. So my line is going to be solid because I have this equality component right over there in my inequality. And so graphing my line as carefully as I can. It's going to go like this. Get rid of the ruler. Arrows at both ends, always. Now, we're not done. We would be if this was just a linear equation, but because it's a linear inequality, we now have to consider the direction that we have to graph and, or the direction that we have to shade, sorry. Think about it this way. Think about it this way. When you have greater or equal to, what it means is you're going to shade above, okay? If you have less or lesser equal to, what it means is you're going to shade below. And one analogy that I like to give people is if you walk into an elevator and you have only 2 buttons to push. One says this, one says this, and you're on the 5th floor and you wanted to go to the 7th floor. Well, you'd have to press this one because if you press the other one, it's going to take you down. Okay, so remember the elevator analogy. So with that, let's go ahead and shade this in. So according to my inequality, I'm going to shade below my line. And so everything below or under or less than the y values of my y values on the line. So if you take any y value on the line, what you want are y values that are below that or, under that. So everything here gets shaded in. Okay. Now, one other thing that I like to do is even though it's not in the directions here, one thing that I always encourage and like to do is I like to test what I've done to make sure that I didn't just fall into a big trap here and get stuck doing the wrong thing. I'm going to choose a point and test it. And the point that I'm going to choose is this one here. 0, 0 is the best point to choose. And the reason is because zeros are excellent numbers for wiping things out when you're doing multiplication. And it's also just a quick way to get this done. So by taking 0, 0, I want to go back to the original inequality, not what I changed into. You go back to the original to ensure that you're testing a point in something that is flawless. I could have made a mistake when I changed it into slope-intercept form. So I don't want to check my 0, 0 and what I changed into. I want to go back to what was given to me at first. So replacing the x and y, what I get is 4 times 0 minus 3 times 0. And I want to see, when I use those numbers, do I get something that is either -3 or greater? So multiplying by 0 means these two basically wipe out, and I get 0 is greater or equal to -3. And now I have to think about this. Is that true or is it false? Is 0 bigger or equal to -3? And the answer is yes, it is. And because it is, this point, this single point in the green zone, is like the ambassador for all the other white points that are in here, which are limitless, countless others that are in there. So if I were to take any of these white points and learn their ordered pairs and test their ordered pairs in the same inequality, what I would get is something that is always going to be true. But if I cross this line and I test something in the part that is not shaded, like right there, for example, if I test this part, then what I'm going to get is something that is false. And so that's why that part is not shaded. One last thing to say about this is you can also borrow a point from the line itself, directly from the line itself. So if I were to take this y-intercept, for example, which is 0, 1, if I take that and I plug it in, I would get a true statement. And this will be my final test for this, and then we'll move on. So my final test for this would be to say 4 times 0 minus 3 times 3 times 1 is greater or equal to -3. That 4 times 0 is gone. I get -3 is greater or equal to -3. And again, you want to ask yourself, okay, well, hang on, is that true or is that false? -3 is not greater than -3, right? Can't be bigger than itself, but it is equal to itself. And the fact that I have this equality component built into that allows me to say that -3 is equal to -3. And for that reason, it's a true statement, just like the other one was. So, true statement. And with that, we're done with this question. Let's go ahead and move on to the other. All right. So word scenario, everybody's favorite. Everyone, who doesn't like word scenarios? I have saved $150 so far for Christmas gifts. I plan to save another $50 per week, and I need at least $375 by Christmas. So you're supposed to write an inequality that represents the total amount of money I have after W weeks. Then we graph it, pick a solution. So we're going to graph it, we're going to pick a solution, and we're going to interpret what it means. Okay, so a lot of tasks, a lot of stuff that we need to do here. And we're going to begin by picking out the important information from this. So I've saved $150 so far for Christmas gifts. You're going to increase that amount by saving another $50 per week. And we're using W for weeks. And you need at least $375. So putting this all together, what I get is 50, this is $50 times the number of weeks plus the amount of money that you started with, which was $150. All this amount, this total amount, which is going to constantly change based on your number of weeks, all this needs to be at least $375 or more. Okay, so I need to use greater or equal to $375. If you put less or equal to, then what you're saying is that you don't want to save any more than $375. $375 would be the most you want to spend. But if you're trying to save money, especially for gifts and things like that, then it's always a good idea to save more, right? More is better when you're trying to save money. So this is our inequality, so we can check that off. And now we have to go ahead and graph this. So in order to graph this, we have to go ahead and solve this, and so if we were to solve this, I'm going to go ahead and step back a little bit. If we were to solve this inequality, then we would have to subtract 150 from both sides. And what we get is 50x is greater or equal to 225. And then if you divide both sides by 50, what you get is that x must be greater or equal to 4.5. Now, because x represents, this should be w, which it doesn't really matter too much. But since they gave us w for weeks, we're going to stick to that. Since w represents the number of weeks that go by, what this answer means is that if you were to save for 4.5 weeks or more, then you would have a minimum of $375 saved or more. So in order to graph this, we set up a number line, and you can drop 4.5 anywhere you like. This is going to be a closed point because we have equality built into the inequality, as you can see right there. And because we're saving because time moves forward is a better way. Because time moves forward, this graph moves to the right. So any value that you choose from the right side of 4.5 would represent that amount of weeks that have gone by of you saving money. And hopefully you can buy all the Christmas gifts you want to buy. All right, on to the next one. We're going to look at a review of systems of equations. Now, systems of equations, this has to do with the idea of two linear equations working simultaneously to create solutions or to create scenarios that where there are no solutions. So we're going to go ahead and begin with this one here, where we have to graph these two linear equations. Now, these are not in any recognizable form, meaning that none of these are with the exception of the second one. The first one is not in slope-intercept form. It's not in standard form. It's not in point-slope form. So we're going to have to take care of that. The second one, however, seems to be in standard form. However, if I look closely, I can see that, hey, my leading coefficient is a negative, and you're not supposed to have that. So this is actually not in standard form either, nor is it in point-slope form or slope-intercept form. So we have to first rearrange things for each equation to make them graphable. So we'll start with the first one. What I'm going to do is I'll first move it over here. So 0 equals -3 plus x minus 3y. What I'm going to do is transform these into slope-intercept form because it's the easiest form from which to graph. And it's good practice of just trying to solve equations and skills like that. So I want to get my y alone. My y is already on the right side, so I'm going to move everything to the left side. So if I were to add 3 to both sides, what I get is 3 is equal to x minus 3y. And then if I subtract x, what I get is negative x plus 3 is equal to negative 3y. Then you divide by negative 3 here, here, and right there. And what you get is 1/3 x minus 1 is equal to y. Okay, now some people don't like when the y is not on the left side. And so if you're one of those people, you can rearrange this and simply write y is equal to 1/3 x minus 1. Okay, if that makes you happier. And then you can go ahead and graph this. So I'm going to put a point at -1, which is my y-intercept. So there it is. Then using my slope, I'm going to go up 1 and 3 to the right. So up 1, 3 to the right. And then I'll put my line last. For now, what I want to do is I want to change this one. So I'm going to change this one into something graphable. So I'm going to move the 5x to the other side. So when I do that, by adding 5x to both sides, what I get is 5x plus 9 is equal to 3y. And then I divide by 3 everywhere. And again, if you want the y on the left, you can just write it that way. It would be y is equal to 5/3x plus 3. And this is now graphable. So I go up 3 times. It's my y-intercept. Now, the slope says go up 5 times and right 3 times. However, if I try this, 1, 2, oh, I'm out. I'm out of bounds. And you don't want to be out of bounds, and you don't want to stretch your coordinate plane to guess where things are. So a trick to doing this, if you run out of space, is you simply go in the opposite direction of what you would normally do. So if I was supposed to go up and right, but I can't, I then go down and left. Okay, I go down and left. And that will take me to the same line, but at a different place on that line. So I'm going to apply that right here. So down 5, 1, 2, 3, 4, 5. Left 3, 1, 2, 3. And there's my point. And now I can go ahead and make my line. But before I do that, hopefully you can see where the yellow and the blue lines will converge together at one single meeting point. Let's go ahead and make that line. Yellow line first. Right there. And blue line second. And there you go. If that's where you guessed they were going to meet, then you guessed correctly. Okay, so the meeting point for these two equations, these two lines, is right there. And this place is at -3 and -2. And it's known as a common solution point. Because if I were to take -3 and -2 and replace every x I see in the original equations, if I replace each x with a -3 and each y with a -2, and I simplify the math, what I would get is a true statement from both equations. And the only reason for that is because they meet together at this one point. This, by the way, is also known as the point of intersection, because that's what they do, right? They meet at that point and they never meet again. All right, so let's move on to the next one. On to the next. So in this equation, we're going to, or in this task, we're going to solve these two equations by using a method called the substitution method. And the substitution method involves taking one equation and making the other one eat it. So in order to do this, we have to make sure that one of our variables, whether it's x or y, it doesn't matter which one, but whichever one it is, you have to make sure that a variable is isolated on one side. Okay, and you'll see why in just a minute. So I'm going to go to this one because that equation looks the easiest. The coefficients are super simple, 1 and 1. I have no negatives to worry about like I do up there, and the coefficients are not something like 8 and 5. So I'm going to target my second equation, and within that, I'm going to choose my x. And the only reason I'm doing that is because it's first in line. So to isolate the x, I'm going to move the y to the other side, and I get negative y minus 1. The reason you want to do that is because in order to substitute one equation into another, you have to first identify what's going to be replaced. You have to identify what's going to be replaced. So by saying x is being identified as negative y plus 1, what that means, what that allows you to do is to now go to the other equation and change the x of the other equation to take that one and change it into your negative y plus 1, what you identified it as. And now you have to rewrite it. So this is going to be rewritten as the following. It's going to be negative 8 times what x is identified as, which is negative y minus 1. And then everything else is the same. So minus 5y equals negative 13. Okay, so now I have something that I need to solve. And so this would be, if I distribute, this would be 8y plus 8 minus 5y equals negative 13. Combining like terms, which are here, I would get 3y plus 8 equals negative 13. And subtracting 8 on both sides, I would get 3y is equal to negative 21. Finally, dividing both sides by 3, I would get y is negative 7. So just like that, I have half my answer. Now, a solution to this involves both an x and a y. And if I only stop at y equals negative 7, I'm only providing a portion of the answer, but not the whole thing. So I need to now work on getting the value of my x. So we're going to get the x. Get the x. And maybe orange isn't the best color to use here. So because my x is already set up right here, it's already set up to give me a value. All I have to do is take the negative 7 and drop it in. So x is negative 7 minus 1, which means I get 7 minus 1, which is 6. And so with that, I'm done. I can say my common solution is at, not negative 6. My common solution is at 6, negative 7. Okay? And with that, I'm done. One little note that I'd like to throw out is normally it's a good idea to, when you want to get the value of x or the value of y, normally it's a good idea to take the known value and go back to the original equations and replace the variable with your known value. In this case, I kind of took the shortcut route, and I trusted that I converted this correctly. But normally it's a good idea to go back to the originals. Or else just make sure that you really know what you're doing so that your work is accurate. Okay, let's move on to the next one. Okay, so same task, different method. So we're going to solve this system, but this time we're going to use something called elimination. Elimination implies exactly what it means. So you have to try to eliminate something in order to make the solving process easier. The benefit of elimination is that the work can be quick. The con to this is that in order to get to the point where it's easier, you sometimes have to do a little legwork. So in this case, we have to do a little legwork. My premise is I want to try to see if I can eliminate my x's or eliminate my y's. In both cases, I am not prepared to eliminate either one, because in order to eliminate, you have to have exact opposite values. In other words, something like this, which makes 0. If you don't have opposite values to make your 0, then you are not eliminating. And so in this case, because neither of these are prepared to eliminate each other, I have to force them to become something opposite of the other. And I start by choosing either my x or my y. And I'm going to go with my y's. So if I want to make my y's exact opposites, and I have a 4 and I have a 3, then I have to choose a common value to turn each of those into. So a 4 and a 3 have a 12 in common. And that's the lowest common value that they both share. So if I want to make this into a 12y, and I want to make this into negative 12y so that they could cancel, what I need to do is ask myself, all right, what would it take for this to become a 12y? Well, I'd have to multiply the 4y by 3. So let's go ahead and do that. We're going to multiply everything times a 3. Okay? Not just the 4y, but everything. This and that as well, because they're all connected to the same equation. Down here, if I want to make this into a negative 12y, I need to ask myself, what should I multiply the negative 3y with? And the answer to that would be, well, multiply it with a 4. But I have to multiply this by 4 and this by 4 as well. So having set all this up for you, let's go ahead and actually do this. So 3 times everything at the top would be negative 30x plus 12y equals negative 84. Multiplying everything in at the bottom by 4, I would get 32x minus 12y equals 88. So sure, some of the numbers have increased in size, but watch what happens next. 12y minus 12y is 0, gone. And by the way, it's incorrect. It would be incorrect to put 0y because 0y simply means 0 times y, which is 0. So don't put anything, just cross them out. 32x minus 30, x is now going to be 2x. And 88 take away 84 is 4. And with that, I know right away, hey, x is 2. So that's half my answer right there. Now to get the other half, which is the y, is now simple because all I have to do is take the 2, choose either this or this, make one of those into a 2, and then solve the equation and you have the value of y. I'm going to go with the path of least resistance, which is this one here over here, and I'm going to replace my x in the equation with the number 2. Okay, so here we go. We're going to get x. So it's going to be 8 times 2 minus 3y equals 22. That's like saying 16 minus 3y equals 22. And if you subtract 16 on both sides, you get negative 3y is equal to 6. And if you divide by negative 3, what you get is y is equal to negative 2. And with that, we are done. And so I can say the common solution, the place where these two equations would create lines that would meet, is at 2 and negative 2. Okay? This is positive 2. 2, negative 2. And there you go. That is the end of the question. All right, let's move on. Word question again. All right. So a word question. Kaylee and Cody each improved their yards by planting daylilies and geraniums. They bought their supplies from the same store. Kaylee spent $106 on 10 daylilies and 9 geraniums. Cody spent $114 on 10 daylilies and 11 geraniums. So our task is to find the cost of 1 daylily and the cost of 1 geranium. So this is a system of equations also, but it's disguised in this word question, this word scenario. So we have to extract from this all the things that are useful, and we have to throw away all the things that are useless. So I'm going to begin with Kaylee. All right. So Kaylee spent $106, and this amount was through buying 10 daylilies and 9 geraniums. So the first thing I need to understand from this is that I have 2 different types of flowers. So I'm going to identify D as my daylily, such a nice name, and then G will be my geraniums. Okay, and that'll be the legend that I refer to all the time, D and G. So for Kaylee, hopefully I'm saying that name correctly. For Kaylee, she spent $106. So $106 was spent on 10 of these and 9 of these. Okay? But Cody, on the other hand, he spent $114. And the way that happened was he bought 10 daylilies and 11 geraniums. So you can see the two equations that we have going on over here. And what I have to do once I set up the equations is I have to determine the best way to solve them with the least effort, and while I'm still showing my work and demonstrating that I understand the concept. So what I see here is a possibility to use the elimination method. And the reason for that is that I see over here 2 terms that are almost ready to eliminate each other. If one of them could only be a negative, then 10 minus 10, or 10D minus 10D, would make 0, and I would be in business to get the value of G. So I'm going to go ahead and pick one of my equations to transform, and I think I'll go with this one. I'm going to multiply this one by -1, because if I want this to be a negative 10D, then I have to multiply that by -1. But remember, doing so means multiplying everything by -1 as well. So let's go ahead and do it. So it's going to be -106 equals -10D minus 9G. The bottom part stays the same. It is unchanged. And so I still have 114 is equal to 10D plus 11G. Now, as I said before, these are going to eliminate, so they're gone. And this allows me to now combine the other terms that remain behind. So 114 minus 106 would be 8, and 11G minus 9G would be 2G. And with that, if I divide by 2, I know right away, hey, my G is 4. And what this means is that one geranium was $4. So one geranium costs $4. And now what I have to do is figure out the cost of a daylily, one daylily. So to get this, I have to go back to my original equations and replace either this G or this G with my 4. It doesn't matter which one, just pick one and do the math. So let's see how this writes here. Nope, I need a brighter color, so I'm going to go with yellow. And I think I'll go with the first equation. So we're going to get, not G, D, the daylilies. Okay, and here we go. So it's going to be 106 is equal to 10 times D plus 9 times 4. And so this is 106 is equal to 10D plus 36. And if I subtract 36 from both sides, what I get is 70. So 70 equals 10D. And if I divide by 10, what I get is 7 is equal to D. And so what this means is that the cost of one daylily, so one daylily is $7. Okay? And with that, we're done. So in this case, the way I write my answer does not have to mention anything about common solutions or anything like that, points of intersection. I have to make my answer relevant to the word scenario, because otherwise the answers alone as numbers are meaningless. So that's why I wrote this out the way I did. Okay, let's go ahead and move on. All right, so systems of linear inequalities. We're getting near the end of this, what's turning out to be a very long video, but I hope it's helping. Systems of linear inequalities are like systems of equations, which we just did, and they're also like linear inequalities. So it's a combination of two categories blended together, and it's called systems of linear inequalities. So let's go ahead and take a look at our first one. Another word scenario. Well, it's your lucky day today, isn't it? So tickets for the ninth grade dance cost $2 each. They are also going to sell cookies for $1 each. They hope to make at least $700. They have to sell at least 100 tickets or they will cancel the dance. Wouldn't want that. Write a system of inequalities to represent the amount of tickets and cookies they must sell. Graph the system, pick a solution, and interpret its meaning. So what we have to do is we have to come up with our two inequalities in order to graph them and find the common solution area, which would give us the different possibilities of number of tickets that could be sold and the number of cookies that could be sold in order to meet their goals. So the first inequality has to be based on the number of tickets or the profit that is made from selling tickets and from selling cookies. So tickets are $2 each, and so I'm going to identify X as being my tickets. And then it says that cookies are also being sold. So they are $1 each. So I'm going to say my Y will represent cookies. So my first inequality will have to do with the profit that they wish to make. So it says they hope to make at least $700. Which means $700 must be the minimum amount. If they make more than that, it's fine. No one ever complains because they made too much money. People would like to make a minimum of a certain amount. So it's going to be this. So the first inequality will be 2x, right? So $2 multiplied by the number of tickets sold plus $1 multiplied by the number of cookies sold must be greater or equal to 700, which is the minimum, the least they want to make. And I put the equality in there because 700 is the minimum. So if they make $700 but no more, then they still met their requirement. The other part of this says that that they have to sell at least 100 tickets or they will cancel the dance. So because the number of tickets is represented as X, the number of tickets must be greater or equal to 100, which is a second inequality. Now, if you're wondering why there isn't a Y involved in this, the reason is because this is only about the number of tickets that have to be sold. It has nothing to do with the number of cookies that are being sold. And so when we graph these two together in one place, it will look something like this. I'm going to switch my screen over here. And I'm going to rewrite the two inequalities that we have. So we had 2x plus y is greater or equal to 700. And we also had just x is greater or equal to 100. And so when you look at a coordinate space like this, coordinate plane area like this, if you're struggling with how to divide the squares so that you can cover big numbers like hundreds or 50s or 10s, one thing to keep in mind is you can always go by hundreds, and then you can adjust your slope so that it changes by the same amount. What I mean by that is the following. First of all, I just realized that I'm going to have to change into slope-intercept form. So I'm going to subtract 2x on both sides. And this gives me y is greater or equal to negative 2x plus 700. Now this slope over here that you see right there, I'll use a different color. The slope over here is negative 2 over 1. However, look at my y-intercept. It's 700. So if you were to go simply down two tiny jumps from 700, it would be hardly recognizable. So what you want to do, and this is a little trick, is you want to move, use your slope to move by hundreds. So I'm going to multiply this by 100, multiply that by 100. So now I have negative 200 over 100, and it means the same thing as just negative 2 over 1, but now when I actually make those movements from my y-intercept, I can actually track it visually. I can see where it's placing me on the coordinate plane. So I'm gonna go ahead and graph this, and you'll see what I mean. So I'm gonna go ahead and label my axes as tickets, and y is cookies. And so I need to go up 700. So 1, 2, 3, 4, 5, 6, 7. This is 700. And that's my first point. Then I go down 200 units. So because each one is 100, I can safely go down 1, 2, and that's going down 200. And then similarly on the ticket side, this is 100. So if I go 100 to the right, I end up right here. Okay? So those are my 2 points. And now I have to decide what kind of line this should be. So going back to what I mentioned earlier, the type of line that you need to use is dependent on the type of inequality you have. So because I have this equality component in there, I have to close my line. So here's my line, like that, all the way to the bottom, but do not go past, because if you go past the x-axis, we're talking about negative values, and we're not dealing with those here. That's why this is just the first quadrant of the coordinate plane. Okay, and then I have to decide where I'm going to shade. So this is greater or equal to, which means I'm going to shade everything above. And I'm going to use specifically the color blue for this. And you'll see why a little later. So I'm going to shade everything above. Just covering my borders here. And here we go. All right, so just shade everything. The reason I'm being a little meticulous about this is because there's something I want you to see at the end. Okay, when I graph the other one. So here, it's all nice and blue. Okay, now I'm going to graph the second line. Now the second line is going to come from my x is greater or equal to 100. This has to do with the minimum number of tickets that should be sold in order to meet the requirement, which is the profit that was mentioned earlier. So with that in mind, x greater or equal to 100 is going to look like this. It's going to be a solid line, and it's going to be a line at 100, and it's going to be a vertical line. Okay, so it's going to be a vertical line. When I took the photo of this paper, it was a little bent, but that's my vertical line. And now I need to shade it. So the direction that you need to shade is dependent on your inequality, and this says greater or equal to. So when you have something that is vertical, greater means to the right, because I want values of x that are greater than 100, and that lies on the right side. Now watch what happens when I shade this part. This is yellow. I know it's a little hard to see, but you're about to see the change happen in just a moment. So this region here is yellow, but as soon as I cross over into the blue, the yellow and the blue mix, and I get green. And the reason this is happening is because I have two graphs interacting. It's like a chemical reaction. I have two things interacting at the same place, same time, and they're creating this result. This green area, which was formerly blue, now green, represents a combination of solutions for both my inequalities. And so if I were to take any point within this space, and I'm going to grab one, let's say I grab this one right here. Okay? And this would be if this is 100, 200, 300, 400. So this is 400. And this is at 600. So if I were to take this place, first of all, it's good to know what these numbers represent. So the 400 represents my x, which as an idea represents my tickets. And the 600 represents my y, which as an idea represents cookies. So the way to understand this single point would be if 400 tickets and 600 cookies were sold, would you meet would the requirements be met for the minimum profit desired? Yes or no? So let's go back to the scenario that we had earlier, where you want to sell a certain amount of tickets and cookies so that you make at least $700. That has to do with the second inequality that you see on the right side. If I were to take my x and y and replace them each with their respective values, what I would get is this. So we're going to check 400 and 600 right here. What I would get is 2 times 400 plus 600 must be something that is 700 or greater. So 2 times 400 is 800, and that is right away bigger than 700. So I already met my requirement, but I'm going to go ahead and continue this. If I add these together, I get 1,000, a profit of $1,400, and that profit exceeds my minimum of $700 by double the amount. So I've more than covered the minimum requirement for this event. Also, if I simply take the 400, which is the value of the tickets, and I replace it into the other inequality, which is right there, then what I get is, for the other inequality, what I get is 400 is greater or equal to 100. And that is also a true statement. And because it's true, what this means is this single white point represents all the other white points within this area, which would be solutions to both inequalities. And that's why everything has to be shaded, and everything changed from blue to green, because it's a combination of the yellow and the blue, the combination of both graphs from both inequalities working together to create this area with all the possible answers you can have for what you want to do. So I hope this helped. Let's see if there are any more beyond this. No, that is the end. So I hope this video helped. I realize that it was lengthy in its making, but I enjoyed doing it, and I hope you benefited from watching. If you have any questions or comments, please feel free to leave them. Make them constructive. I always like to know how I can make my videos better. So please be clear in how you feel I can do this. And as always, thanks for taking the time to watch. Take good care. Bye-bye.